And then finally, in this final chapter in the Lighting Essential Concepts course, we're going to take a look at combining static and dynamic lighting. In general, we're going to do a recap of some of the information covered in earlier chapters. And because it's a lot of different information, a lot of different ways of approaching more or less the same problems. So we're going to do a recap and see how we can combine all of the things that we've covered in a single environment. In this case, there is no start level to work with, so there is no level in start assets, but I'm located in lighting and rendering, essential concepts, finished assets, and there's a level here called combining static dynamic lighting, which is the level we have over here. I'll make the screen a little bit bigger. And this is essentially everything that we just covered in previous chapters combined into a single environment. And we can take a look at how that was done. So first of all, let's start with the outdoor lighting. There is a skylight placed here, which has been set to static. The cube map was increased from the default size. It actually captures a reflection cube map, something we'll cover much later on when we talk about reflections in a later course, but it has a fallback reflection cube map inside. We increased the size of that, and I increased the sky distance as well, or I think I lowered the number, in order to better make it capture the sky that we have over here and use it for the lighting of the environment. Most importantly, it's set to static. Most of the time the skylight will be set to static because it doesn't cast a very well defined shadow and it's usually rather subtle, and we do need it to bounce the light very well. So static is usually what it becomes. Then we have a directional light here, which is set to stationary. Because again, it gives us the best of both worlds. We now have animated shadows here, which is using cascaded shadow maps with these settings. So I brought the range down back to 5000. Beyond 5000 units, it switches to distant field shadows. So we still have shadows pretty far away because of that. And you can see it's enabled over there, and we changed the range of the distant field shadows. But inside the apartment, we still have the bounce lighting from the directional light, which is great, while not losing the sharp shadows here either. We also did the same thing for any other light that is very bright and has a well-defined shadow, which means these 3 spotlights. So all 3 spotlights are set to stationary because we'd like to have this very well defined shadow over here. Same for example, the plants as well. That also happened to the light we have over here, which is stationary as well for the same reason, well defined shadow coming from the cap of the lamp. However, this light over here, which doesn't really do much at all, that is set to static only. It doesn't cast a very bright light, it doesn't cast a very sharp shadow, it's simply there to light up the environment a little bit, so static was good enough for that. I also probably couldn't have made it stationary because we're getting too many stationary lights overlapping probably within the same area, which would have invalidated one of them. You can immediately also see the difference in quality. You can see this is pretty low resolution. It's actually not entirely centered above the lamp either, but it's pretty low resolution compared to the shadow we have over here from stationary. Same applied to the light we have in hallway, static as well. In this case, there is no movable light anywhere in the environment, simply because nothing required a movable light to exist. In a further course and chapter, we're going to create water caustics for underneath the water surface here, and that's a very clear example of something that would have to be movable. If there would be a light that would have to be toggled on and off, for example, let's say you can use this light switch to toggle the light inside the hallway on and off, then that too would have been movable. But in this particular example, there simply wasn't any need to have anything set to movable, so everything is either static or stationary. And then lastly, before we wrap this up, I just want to briefly mention something about the light map sizes as well and ambient occlusion. So light map sizes, when we went over how to create a light map, I put the size of that light map to 1024. In fact, if I right click on the walls of the apartment and we do edit house sm underscore house 1, and we look in the properties here, we can see it's actually even set to light map resolution 2048. That's big. That's more or less the maximum. But if you look at, for example, the book over here, something small, that is set to 32. So just want to put this straight. You usually use pretty small numbers. Most models you will import and configure for light mapping will be 16, 32, 64, maybe 128 in light map resolution. If you would start looking through the environment here, you will notice what has been set to what size. See, the vase, for example, is 64 and so on. So they're all pretty small values. If you would set every model to 1024 or 2048, you will most definitely gonna have issues. Memory-wise, rebuild wise, build lighting wise, and so on. So please only set the most important and largest models to large sizes. Everything else should be kept small. In this case, this mesh has a high resolution light map, and this mesh inside, maybe one or two more, but that's about it. There is a view mode here, the lit button, optimization view modes, and then light map density, which shows you the density of the light maps, and you can use this to create a more uniform size for the light maps. And you can see in this level it's very much so not uniform. You can see the floor and the walls are a very small scale, whereas obviously the couch here, for example, is a much bigger scale. So ideally you would go through and try to bring everything down to roughly the same color and size of light map for consistency's sake. And finally, by the way, there is ambient occlusion active within the environment, which is not the distant field ambient occlusion that was covered in an earlier chapter. In fact, it's baked ambient occlusion via settings, world settings, light mask settings, so where we change the quality, and you can see what quality we use, by the way. And then here we enabled use ambient occlusion and we configured the settings. So it's just pointing out that's another thing you can do. It's optional, it's definitely not required, but it can give that little extra detail to the environment. And also you could turn off light map compression for the absolute best quality, but you probably shouldn't do this unless you're making some type of architectural visualization or similar. You should never turn this off. For games, please keep it enabled because it will get heavy. Right, and that wraps up this course on lighting essential concepts. So we've done a quick recap on all the different settings, and in particular how to combine static and dynamic lighting, and some brief words about ambient occlusion, baked ambient occlusion, and light map resolution.